Good morning. Welcome to lecture 35 on thermodynamics of materials. Today I will actually uh, okay, I'll give you actually the summary of some statements. Okay, let us see. Summary. Summary of the second law statements. Giving the condition of impossibility. I'll summarize this. Impossibility. Number of impossibilities we have come across. So I'll summarize this. Remember, the second law may talk about impossibility, but this same second law will actually give a clue how to make an impossible process possible one. So this we will also see. So, but let us first jot down this what is impossibility. Giving the condition summary. We have already read two. What is this? One, say one. What is this? I am writing eta irreversible cycle, efficiency, irreversible cycle is greater than or equal to eta reversible cycle. This is an impossibility. Reversible cycle is maximum. Greater. Okay. So it will be less than that. Okay. But so greater than is impossible. Impossible is what? Greater than. This impossibility is greater than. Second. Another I is there. Reversible cycle is what? Last class is what? Reversible. I am talking about reversible. 100%. That is the impossibility. It is 100%. Because this is what statement? Kelvin-Planck statement I gave you last day. The concluding thing, that is, this is called Kelvin-Planck statement. Statement also known as, you should note this, or sometimes Thomson statement. Kelvin is Thomson. Also known as perpetual motion of the second kind. Also known as perpetual motion of the second kind. You should note this, otherwise you will be actually baffled. You will not catch the statement. It is actually this. Perpetual, this is impossibility. Perpetual motion of the second kind. And then third, I will give you today, actually I will discuss this. Next is, that is heat flow from this barrier from low temperature to high temperature. In an isolated system, you have to say, in an spontaneous heat flow from low temperature to high temperature in an isolated system. That is best. This I will discuss. This is known as what? Clausius statement. The culminating statement actually. Okay, wait, Clausius statement. This is actually, this is also impossible. Heat flow from low is impossible. So impossible. Eta reversible cycle 99% possible. 100% is forbidden. Okay. So this is these three. Still another, I will give dotted line that you should note also. Still another one known as perpetual motion of the first kind. Okay. This says what is the statement? This first is what? It is not possible. Statement. First kind. The statement is what? It is not possible to convert heat into work in a cycle. In a cyclic process. Heat into work in a cyclic process. Okay, see my point? Okay. Heat into in a cyclic process. Okay, it is cyclic process. So this is actually, this is note, this is why named first kind, this is second kind. The difference is this violates the second law. This violates the second law. This violates, that is hence second. This actually I have understood. No book has written this, but this I have followed. Many things actually I have followed myself. Okay, I have understood, I have simplified, I have interpreted many. You'll see. So you can try any book, any textbook, any number of texts. Second kind means it is violates second law. This is up to second law. So this universe is, if you do this, negative. I showed other day. Second law. Okay. So this is violates the second law. Violates the second law. Hence second kind. And this does not violate the second law. This is about the first kind. First law. Violates the first law. So that's why it is different kind of impossibility though. So that's why I given dotted line. Another. Violates the first law. First law. How it is possible? You could check this. This is explanation. Star. I'll remove this. Explanation. I'm writing. First law. dq is du plus dw. Is the first law. Right? First law. Hence I have said that this is about the first law. This is my understanding. Okay. So in the cyclic and integration. What is this value? So no, possible to perform work without any heat input. To convert into work, to perform work. I'm very sorry. Without any heat input. I'm very sorry. Correct. What is impossible? To perform work without heat input. Without heat input in a cyclic process. Note, in a cyclic process, no problem. Let us check. I have considered what? Cyclic integration. So what is this value? 0. So without any heat input means how much? If it is 0, if this is 0, this leads to this 0. If no heat input, no work. Cyclic. Violates the first law. Okay? If it is 0, no heat input in the cycle, no more. Okay, sorry, easy, very easy. So violation of the first law, not the second law. Violates the first law, not the second law. Impossible. Actually, can you tell me, is that follow this? Sometimes we come across some statements, or say I am asking you, suppose, to perform work without heat input, suppose cyclic, this condition I am actually withdrawing. In any process, to convert work without heat input, follow my question, simple simple-minded, simple question. To convert work heat into what? In a process, any process. Is it possible? Is it impossible? It is also impossible. It is not possible.
It is changing internal energy can do. Changing internal energy. Like this would be there.
And because it is impossible. It is possible. Yes, why it is possible? I am not giving any heat, but it is. You are right. I am not giving any. No system is not giving any heat, but still system will do what?
No, so in every system there is no heat exchange.
Good. Still work. That's right. That's right. Because single path, not cyclic. The moment cyclic gone. So careful. These are very easy statements. Now to you everything is easy because you can write these statements. Yes, so over. These are the summarization. So I will actually today I will discuss this Clausius statement. Sure. So this is Clausius. This will be discussed today. Will be discussed today. So I remove this. Okay. Start. Clausius statement. What is the Clausius statement? Impossible. It is not possible to transfer heat from as I told you, remember, I'll return your answer papers soon, very soon, maybe this Wednesday I propose. You extract some time, actually, not the regular class, extra class. I will answer papers, okay? One period discussion, marks discussion, etc. So I propose Wednesday first period if possible. You check, let me know, okay? But I'm ready for Wednesday, means day after tomorrow. It is not possible to transfer heat from a cold body to a hot body. The first class test marks, I said. To a cold body to a hot body without in the same process converting a certain amount of work into heat. This is the original statement, 1867 perhaps, 1867. It was the conclusion of these statements, okay? Converting a certain amount of work into heat, okay? This is, I actually propose this one without, and that, or you may write alternatively, you can write this I think without, I'm writing once more, without in the same process performing or doing some work on the system. Is underlined, on the system. The same meaning, same thing. Work without in the same process doing some work on the system. Okay, that is converting some work into heat. Okay, this I will explain. People, these letters. Okay, I am removing this side. Okay, this side I may remove. These are all over. This side quickly. 5 minutes. So you have classes, mechanical. So this thing, okay, careful. So what is I want to start? This proof I am showing. And what is the universal proof? Universal. Any impossibility, possibility means spontaneity, irreversibility, or equilibrium, reversibility is what is the rule? That statement. That's the universal statement. The laws, the second law, which is known as the second law. Keep it always, like first law you have always read it. Here also. Yeah, okay, all right. Second law is means ds universe is either greater than equal to or equal to. Remember, recall greater than refers to irreversible or spontaneity, spontaneity, and equals to is reversible process or equilibrium. We'll use this concept or chemical reaction equilibrium, but reversible process, okay, equilibrium. And another, you note this, and less than refers to impossible. Okay, less than I have not given. So this is remember, never forget. So start. Okay, let us consider this. Let us consider this is the. Let us consider two bodies of same same mass and two identical bodies with same mass and same mass, same size, and same, okay, what is this called? Same size, same mass and same, same mass and same, heat capacity and same heat capacity. Identical, so it will be same heat capacities. Heat capacity. Say two identical blocks. Say two identical blocks of copper. Just for example, blocks of copper I have taken. But which look on same, but at two different temperatures. This is the beginning point. I will sketch this statement. Okay, what is the situation? Sketch isolated system. I consider at different temperatures taken in an isolated system. Why I often consider isolated system? I told you why often we consider isolated system for spontaneous process. Spontaneous process is easy to identify in isolated system. Why isolated system? Because no outside help. No help from surroundings. No influence from surrounding. No interaction with the surrounding. Alone. Isolated means alone. It will move freely, means spontaneously from one state to another. So that's why isolation is necessary. Okay, not interfere by anything else. So isolation. And example is, yes, heat will flow. We know actually, heat will flow from high temperature to low temperature. This we know. And we are considering the opposite. It is not possible. Let us see why. But without means it can be made. Yeah. This part is, second part is, it can be made. Interesting. Let us see. First we consider the spontaneous. Yeah. Heat flow from high temperature to low temperature. Let us consider two blocks of copper. So what is this? On this copper temperature is okay. A, call it A, temperature T1, and B, call B, but identicals. Two copper blocks, T2, same mass and same nature, same material. So copper T1, T2. Given this, T1 is high temperature is T1. This is the initial state 1. This means what? This I am drawing for what? Isolation. Isolated system. Do you recall what is the condition of isolated system? Constant internal energy, volume, and if you add again, this is missed in books, but I add constant, no non-mechanical work. Okay, that's it. Exactly. Then it will be fantastic. Isolated system. And then what? This moves state 1. This is state 1, and there is a partition. This partition I have not snapped yet. I have not snapped yet. So they are actually maintaining two temperatures with partition. Now the state 1. This is snapped. This partition is snapped. So what will happen? The moment it is snapped, so this is snapped. So there will be heat transfer and there will be equalization of this, as if A will attain, B will attain the same temperature, namely T3, okay, both will be same. And T3 is same mass, it can be shown that T3 is nothing but the midpoint. Same mass and heat, same heat lost, same heat gain. Okay, the loss and gain is same. So it will be halfway. Halfway means T3 will be T1 plus, obviously. So it is 30, it is 30, it is 40. 5 they will meet, 35. Easy. So this is. Now, this is what? This is isolated. In isolated, this is going on. So, state 2. I will see what is the delta S. Now, delta S for the process, delta S 1 to 2. 1 to 2. What is this? Tell me, delta S is what? Nothing but, hello, who are talking? Delta S 1 to 2 is what? Delta system. Delta system. And system is comprised of two stuff, A and B. So what is delta S A? Change on this, change on that. Okay, A and B are copper, made of copper. Okay? So delta S is what? C is a constant volume, internal isolation system, constant U, constant internal energy, constant volume system. So you can see delta S 1 to 2 is what? It is moving from T1 to T3. So NCB, N moles, ln Cb of copper, if it is copper, ln T3 by T1 plus NCB ln, this also T3 by T2. Happy though? Quickly, what we have considered spontaneous process or impossible process? High temperature to low temperature, heat flows from high temperature to low temperature, then higher temperature reduced and lower temperature increased, so and becoming equal. So we are considering heat flow from high temperature to low temperature, which is a spontaneous process. Let us see what is the delta S universe. Spontaneous process should be greater than 0. Let us see. Let us see what happens. Okay, we will examine every statement with this statement. This is universally true. Second law is this. These are many languages, so this actually just clear, mathematical. So what is this? NCB ln Tt square by T1 T2. I keep it there. Now a little bit. Now will this T1 minus T2 square is what? Positive though. Is positive though. Is what? T1 plus T2 square minus 4 T1, little bit high school, minus 4, that means this is also positive, or T1 plus T2 by 2 whole square is greater than T1 T2. This is positive means divided by 4 is also positive. If it's 4 by positive means this side is greater than that side. This is greater than that, divided by 4. So it is T1 plus T2 by 2 square greater than T. What is the name of this? T3. This is T3. So can I start this? So I remove this part. This you remove. Or what you are getting? Or T3 square greater than T1 T2. And what is your equation 1? Quickly. So from equation 1, we are getting what? Equation 1, what we are getting? Delta S 1 to 2 is a system moving from one state to system. Delta S system. What system? System, you can write 1 to 2. You can write all these things. System is what? Is what? T3 greater than is what? From 1, numerator is greater than denominator. So delta system is what? Positive. Oh, makes sense. This makes sense. DS I have written, you can write delta S also for finite changes. Original DS, anytime DS, you can integrate, anytime. So it is better to start with DS. We'll always start from the scratch, differential integrated this. But dH is not H. dH is not H. This is the change. D refers to change. Or say ds is not S. Anyway, you are right though. ds delta system is positive. Delta system 1 to 2 is positive. Happy though? So this verified as expected. So as expected. So in compliance with the second law. With the second law statement. Actually, call it 1 best. So second law 1. With the second law statement 1. Okay. Compliance, and we are happy. So today we understood why heat flows from high temperature to low temperature. We say, oh yeah, heat will flow from high temperature to low temperature. Why? It will flow. It will flow does not explain the things. Saying number of times doesn't explain a thing. A natural process. Why this happens? Any science? No, every day we see this. Every day's experience is not any explanation. We are feeling notion. We have actually idea. Like water flows from high temperature, high level to low level. Current flows from high potential, electric potential to low electric potential. So everywhere you are seeing the same thing. So heat flows from this should be. But no. What is the reason? Reason is this. This is given by the second law. Second law says since delta S associated, delta S of the universe associated with this process has a positive. Delta S is a positive value. Or that is an increase in entropy. Hence, this is the general explanation. Okay. So for all processes, all spontaneous, this is no exception. Heat flow. So we are satisfied. This part is okay. First part, it will not flow. Okay. Another thing is this system, but universe. That is universe. What will be your comment? So delta system not delta system is delta universe is what? Delta system plus surrounding. Plus delta surrounding. What is the delta surrounding in this case? 0. It is not participating. Isolated system, it doesn't know what is surroundings like. No presence of surrounding. So this is not operating here, non-functional. So 0. So delta system. So you are all set that delta S universe has been positive. So this is also positive. So you are all set, sir. Fine. At least this. Now next part is very important. That we will take up. Can heat be made to flow from low temperature to high temperature? Impossible thing. This is impossible. Can it be made? We will discuss this, okay, for 10 minutes or 15 minutes on this. First of all, we consider, okay, this, I actually tell you what. So, I tell you what. So, delta system, so, you follow, why it is impossible in an isolated system. So, delta S system, 1 to 2, 1 to 2 though. Here, as I showed, is what? That is nothing but S2 minus S12. System at final state entropy. System undergoing a process 1 to 2. System moving from many ways of talking. 1 to 2 is the process. System moving from state 1 to state. So what is the delta S? This is system. Is what? This is positive. What is the path? Heat flow. This is the reversal of it. The reversal of it. Why it is impossible? Heat doesn't flow ever from low temperature to high temperature. Why? Again that. Resort to that. Why? It will explain. Why does not? So the reversal of this process is delta S. That is heat flow from low temperature to low to high temperature. Okay? Is what, sir? What is this? That means system will be taken from state 2 to state 1. So that is reversal of this delta S system 2 to 1. Let us consider 1 to 2, 2 to 1. This I will discuss. Low to high I will discuss this. Okay. Delta S 2 to 1 is what? If we want to reverse, S1 minus S2 is what? Negative. That means impossible. That must be the impossible thing. So impossible where? So the reversal of this process in the same isolated system, in the isolated system. In an isolated system, the isolated system I consider, in the isolated system, in an isolated system, do this. In an isolated system, no, suppose low temperature, high temperature, heat will not pass from low to high, high to low only. Isolated system. But how is it possible to transfer heat from low to high? Clue is, second law clue or Clausius statement clue, break the isolation. Otherwise no hope. I am giving you everything. 15 minutes discussion is coming. It will move, it will be possible if you break the, in isolated system impossible. Make sure, it is over, concluded. In isolated system, heat will never flow from low to high, high to low, always. Or from you consider equal to this, same thing, I will show you. Low to high. Impossible isolated. But you break the isolation, then possible. What is the kind of, means you have to bring in surroundings into intervention, okay? Into action. And that will interact with this and do what? As I give you, doing some work on the system. I am giving you the final thing. Is it possible low temperature to high temperature? Is it possible? Yes, it is possible. By bringing in the surroundings, we will do some work on the system. What is the example? Low to high, refrigerator. Heat is flowing from the refrigerator, which is cold, to high room temperature. The outside room, your bedroom, where it is kept, bedroom or say, whichever. The room. So low temperature to high temperature, heat is flowing. But how? Work done on the system, not isolated. What is that? Who is doing work on the system there? The compressors. They install a compressor at the back, and that is actually condensing the fluid, refrigerant, freon. Okay, circulating fluid, freon, are compressing and extracting heat, and that is passed to the atmosphere. Okay, with the help. Okay, so that is actually, so that is the answer. So I will actually show you here. You follow this quickly. I have a lot of discussions coming. You follow this. Suppose two bodies, A, B. You follow. What? 40 degrees centigrade? 30 initially. Temperature, this is our T1, this is T2. You remember we ended up at T3. Spontaneous process follow the spontaneous process. When it high temperature greater than low temperature, so heat will flow from high temperature to low temperature, means it will reduce the higher and will increase the lower. Decrease the higher, increase the lower. So decrease like 39, then it becomes 31. Okay, then it is, when it is 38, it becomes 32. When it is 37, same mass, same heat capacity, 33. Then when it is 36, sir, it is 34. Still heat is transferred. Then when it is 35, equal. So this is actually state 2. This is your state 2. Right? This. Can I remove this? This is all over. Remove this. This is your state 2. State 2. This is your state 1. So state 1 to state 2, heat flow from high temperature to low temperature spontaneously, and system, what is the delta S 1 to 2, as I told you, is actually so state. So moving the movement of system from state 1 to state 2 try to follow what has happened here. See, this is the language. Heat flows from high temperature to low temperature. What shall I do with this? We are actually interested in state property, change of state, such thing. Heat flows from high temperature to low temperature is spontaneous. And this is about the state, delta S, S2 minus S1. So we have to reconcile. So what is the reconcile? Yes, sir. Heat flows from high temperature to low temperature means system moves from state 1 to state 2. That I am going to write. The movement of the system from state 1 to state 2 is accompanied by which we use by the heat flow from state 2 state 1 heat flow from high temperature high temperature to low temperature. So they are saying heat flows from high temperature to low temperature spontaneous. You say state 1 to state 2. We will use in thermodynamics states. We don't actually understand this language. Okay, if that should be language converting to state. So at low temperature, okay. Now you see, I consider this taking system from state 2 to state 1. State 2 to state 1. So now the movement of the state, hence the movement of the state, similarly movement of the system is from state 2 to state 1. You write paraphrase from state 2 to state 1 is what? Accompanied by heat flow from low temperature to high temperature. That's right. So when you say high temperature, this is the idea. This actually I would prefer. Low temperature, high temperature, converting to state. So when heat flows, so here to here, while low to high, I am explaining. Follow this. You are all set? So you see why it is impossible. So why this is impossible in an isolated system? Low temperature to high temperature. Follow this. I follow first high to low. What happens? Oh, heat flows high to low. That's why higher temperature becomes lower, is reduced, and this is decreased. This is increased. Lower temperature increased progressively. Decrease, increase. Because heat flows from this to this. Follow. Heat flows from this to this, down, up, until equal. Here what will happen? Heat flows. Here you start maybe here maybe convenient. Okay, don't worry. Here you can start. Here no doubts. Should start here. Here you follow. High, low. Which is high? This is high. I move the reverse direction. High temperature, low temperature. What is stated? I want to get the heat flow from low to high. What will be the result? Lower will be lower. Lower will be still lower and higher will be still higher. Repeat. What is this? Heat flows from low temperature to high temperature. That means this will give heat, so it will be lower, and this will be higher. So 34 to 33, 36, 37, 33, 32. It becomes 30. So it is moving from state 2 to state. Here it is equal actually, but same actually. So state 2, state 1. So when he said heat flows from low to high, impossible, you will say it is taking the system from state 2 to state 1, which is impossible. And that is clear because this is S1 minus S2. S2 is what? That is here. That is, if S2 minus S1 is positive, S2 minus 1 is positive, S1 minus is negative and impossible. This is S2 positive is right here, spontaneous. Okay, spontaneous. Yes, sorry. Happy. This is the first message. Okay. So now we want an actually working principle. How this? Okay. So next question is, I'm removing this. Actually, one thing. You see, let us compare first law and second law about the. Let us give a question to the first law and to second law each. I'm putting a question to each law. Can you give me the direction of spontaneous direction? Which a process will occur in? Which direction? High temperature to low temperature to high temperature. What is your opinion on the first law and the second law? Second law has already given, but let us discuss it. So the superiority of the second law over the first law. Over the first law. Okay, with respect to okay, giving the spontaneous direction of heat flow, say heat flow. Consider this. Start. You follow this? Heat flow. So consider isolated system. In an isolated system, as we are considering in an isolated system. You follow. So state 1 and state 2. Which way system will move? Follow the state 1. Here, state 1, same. State 2. Ask the first law. First law, you ask the first law. The whether heat will flow state 1 to state 2. The figure. Refer to the figure. Refer to the figure. Refer to the figure. Figure already shown. Ask first law. Which direction heat will, the process will move spontaneously, this way or that way. State 1 to state 2, state 1 to state 2, or state 2 state 1. First law. What is the answer? Spontaneously. Isolated system. Okay. First law. What is the weapon of the first law? First law has some gadgets. Okay. Has some tools. It uses. What is that? You know. Internal energy. Internal energy is a tool. Or enthalpy. Not entropy. Entropy second law. U. Now what will be the state 1 and state? Remember, this is an isolated system. What is that? What is isolated system? Hello, you are talking. Okay. What are you doing here? State 1 to state 2. I am so absorbed back here that you are actually in the meantime you are talking. You are come here to talk around. So state 1 to state 2. So I say first law, a powerful law, supposedly. Internal energy is a tool. It will use its tools. Okay. What is in an isolated system? What is the U value? U value. U. Written somewhere. Constant U. So if it is U1, can you discriminate? If you say that if this will move to this, then why not this way? The answer, what is the answer? So no discriminating feature. No discrimination. Cannot answer. As good. If the system can move from state 1 to state 2, it can move from state 2 to state 1. So no discriminating feature. No. Can I remove this? You don't mind, I hope. No discrimination. No discrimination. No answer. That means no answer. That is no, hence no answer. Hence no answer. Ask the second law, same question. Put the second law. Second law, what is this? What is its weapon? Second law weapon is entropy. Second law uses what it says? It is S1, where it is different. S2. And there, which is greater? Which is greater? Not equal. So discriminating. So discriminating. 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 So discrimination. And what is the answer? The system moves from state 1 to in a spontaneous way. In a spontaneous way. This is the answer. Isolated system hence in a spontaneous way. So this answer you got. So this is additional talk. I actually wanted to impress upon you the importance of second law. It says, but first law, okay, he says, what is the direction? Is okay. Then you see, very interesting, spontaneous direction is moving from low to high entropy. Normally, spontaneous direction is what? Say, consider water moves from high gravitational, gravitational energy to low, high level to low level, high gravitational to low gravitational. Heat flows from high temperature to low temperature. Energy flows from potential high to low. Even this energy you will study, energy high to low you will see. What else you know? Electric potential, electric current flows from high electric potential to low. Everywhere high to low spontaneous. Here, surprising, low to high. Actually, entropy is not energy. Other energy, high to low. So this is very. This is the movement of the system from low entropy to high entropy. In a spontaneous process, is unlike others, is unlike energies and others. Heat, energies and others, gravitational energy or say electric potential, etc., like energies which moves from high level to low level spontaneously. So you should be careful. Note, entropy is not energy. Note, entropy is not energy. Entropy is not energy behavior. What is the unit? This is what is the unit? Joule per Kelvin unit. This you know actually. Next vital question. I'll take up. You are talking too much. You two guys, I have some actually. You first of all, you gentlemen, what is your name? Kuntol. Kuntol, will you stand up for a while? I'm asking you a question. You have completed higher secondary? Sure. Tell us, we are interested to tell us the second law of Newton's second law of motion. Just I'm verifying whether you have passed, how much you have read. Actually, this is prerequisite in higher secondary, good higher secondary, nothing else. So tell us the second law of motion, Newton's second law of motion, segment only will do. No, you should actually have, what else? You cannot, no one can afford to forget. You tell anyhow. What is the mathematical form? That will do also. That will do. Second law of motion. Which you remember in high secondary? Anything you remember high secondary? Tell us, I'll ask from that. Hydrostatics? Oh, have you passed? You have passed and you don't remember anything. What's the use of studying this? You will remember just next day. You forget. Hello. Tell us. Sit down. What is the statement of the second law? Newton's second law of motion? You don't know? Oh, and you have passed. Okay, what you have done? Oh, you have not studied after class 10. Diploma, fine. Which place you are from? Which place you have done the diploma? Which place? HIT is what that? Oldia. So we have started. Have you come across the name? In second motion, Newton's law of motion. How many laws are there? 3. He says 3 and you see, he may be worse than you. You don't know. If I start asking, he will be even. Sorry, I figure. Oh, you know, sit down. You know. Tell us, what is the Pascal law in hydrostatics? Hey, hello, quiet.
Pressure at a point is forward. Pressure at a point is equal. Something like that.
Here, this is a total disregard for your studies, okay? So I don't have time actually. I could have actually sorted out who are actually what. Yeah, I could have easily. Many comments are coming, okay, about this. Oh, he is very jubilant. Oh, his name is Satya Sadhan. What is the name? His name? Sachidananda Babu. Okay. Okay. Do you remember any law? Any law, for example? What is the first law? Acha, okay. Don't have to lengthy. You tell me what is the difference between dyne and 1 gram weight? Just any character you say, I will be happy. Anything you say. 1 gram weight, it is a unit of what? Now, what is the unit of which? Pressure or density? Oh. So what is this? What is the difference? What is the difference? What is the relation? What is the relation? Hey, hello, what are you doing? Ayush? You must be Ayush or who? Ayush is where? Ayush is here. You are who? You are who? Sit down. You are also lateral, regular. Oh, that's why actually you are saying here, force, lateral. Okay. Next question is, let us take the most interesting one. So how is it possible? Next question. 2 minutes. It's almost done. After 2 minutes, I will actually complete. How is it possible to transfer heat from low to high? To transfer heat from low temperature to high temperature quickly. Acha, I will not write this. I will not write anymore, taking time. I will write next day, but I will discuss this. You hear me? Answer this. Low temperature, high temperature. What is the solution? I said, acha, I am giving a general solution. When you have this type of problem, impossible direction, or you know the spontaneous. The heat flows spontaneously from high temperature to low temperature. Then how will you tackle this? The reversal of that. How to possible? That is impossible. Should be impossible if it is an isolated system. If no help is given, no support is given. The answer is, you will say, sir, this spontaneous process, heat flowing from high temperature to low temperature, I will carry out reversibly, or you carry out reversibly. If it is possible, then what you will do? Reverse it. And a reversible process is supposedly reversed, can supposedly be reversed, then it will be low to high. Okay. Repeat. High to low, spontaneous. Carry out reversibly. How will you carry out reversibly? Okay. Tell me, how will you carry out reversibly? Any example? I am giving the clue. Next I will tell you. Don't make noise at this stage. Okay. Height is where have you got an example? Heat flowing from high temperature to low temperature, going reversibly. Reversible Carnot cycle. Heat flows from boiler to atmosphere through this device called engine. That is an reversible cycle you have read it. And now you reverse this. Then it will be opposite. It will be flow from low to high. Next I will discuss this. Teacher is there. Okay, thank you. With these words, actually we have completed today's class.